Welcome to IB Maths Made Easy. This is Sets and Venn Diagrams, so let's get into it. So, a bit of set notation to start off. This sort of E thing means is in. So, mind my terrible handwriting. I'm left-handed as well, so I might smudge. This N bracket A, so in the set of A, how many elements or how many numbers? This little sort of horseshoe shape with a little line is the subset. That's the subset symbol, and it sort of means that it's sort of like a second group number. So say you have a set B of all even numbers, and then you have set A of 2, 4, and 6. You'd say A is a subset of B. So A, that, and then B. And then this horseshoe without the line means proper subset. So it means if every element in A or every number in A is the same as every element in B, but they're not the same. So it's a bit hard to wrap your head around, but yeah. So that's just a proper subset. This sort of N or upside down U, whatever you want to call it, that is an intersection. So that means if you have a set A and you have a set B, that is all the elements that are in both. So the way I remember it, it's an N. Sometimes people, when they say and, they just shorten it to N. So you say A and B. So in a Venn diagram, that would be this section in the middle there. So that is a intersection. And this U is a union. So U for union. And what that means is if you have three sets, A, B, and C, A, U, B means A or B. So you have A, B, and C. So A, U, B, A union B is all of this. Anything that is A or B. So that includes the intersection of A and B. So we'll say that's A. And just one final thing. So if you have a set A and you have an apostrophe next to it, that just means not A. So everything that is not A. So that is not. And that is just about all the notation that you'll need. So with that out of the way, now we can start doing questions and start trying to figure out solutions to all the different problems that we have, and we'll be well on our way to mastering this topic. Now on to some common number sets that you'll find. So we have N, Z, Q, and R. Those are the four main ones you want to remember, and that is also the order you'll want to remember them in. So that goes from the largest of them all, R stands for real, then Q, rational, Z, integers, and then N, natural. So N is inside Z, Z is inside Q, which means N is also inside Q, and all of these are all inside R. So what N stands for is natural. Natural numbers. So that is all the counting numbers, so 1, 2, 3, 4, 5, but also 0. Remember, 0 is also in it. So all those numbers that you'd say when you're counting up, including 0. Now Z is integers, and what that means is basically any whole number. So it includes 0, 1, 2, 3, but also negatives. So negative 5, negative 57, as big or as small as you want. So we'll just put negative 1, 0, 1, all that. So what Q stands for is rational. So what that means is any number that can be represented by a fraction. So even recurring fractions, say 1 over 3, that is rational. And then all the whole numbers, because anything over 1 is just itself. So say 7 over 1, that's just 7. So that's rational. And then real is a bit strange, but is basically anything that can be placed on the number line. So that is irrational numbers, root 3, that includes pi, includes basically everything except imaginary numbers, but we don't need to know that yet. So real, that's basically everything. Now for a bit of practice on the number sets. So we're just going to look at these 5 numbers and we're going to put them all into, see which sets they're in. So, starting with 6. Is it a natural number? Yes. It's a counting number. 1, 2, 3, 4, 5, 6. So, yes. Which means it's also an integer, also an irrational number, and also a real number. So, 6 is in all of those. Now, negative 3 over 8. Is that a natural number? No. You don't count 0, 1, 2, 3, negative 3 over 8. It just doesn't work. So, it's not a natural number. But is it an integer? No, it's not as well. It's not a whole number, so it's not an integer. But it is a rational number because it is represented by a fraction. So we can put yes for Q, and as such we can put yes for R. Now, pi over 2, bit of a tricky one. By now you should know it's not a natural number, not an integer, but you might be thinking it is a rational number because it's represented by a fraction. But actually no, because pi is not a rational number. So we can say no, because pi is the diameter over the radius or whatever, 3.14 forever. So that one is impossible, but it can be shown on the number line. So we'll put a tick there. Now, root negative 3. We know that there's not a root of a negative, so from that automatically you should know that it's in none of these. What it would be though is an imaginary number, but we're not doing that at the moment. Now for a slightly different one, negative root 3. There's a big difference between root negative 3 and negative root 3. So to start with, we know it's not a counting number, not in the natural numbers. It's not a whole number as well. You don't get like 2 squared equals 3, it's 4, and 1 squared equals 1. So there's nothing in between. It's not a natural number. Maybe root 4. Root 4 would fall into this thing because it could be 2, but not negative root 3. Now, for rational, root 3 is not rational, so we'll put an X there. But real, is it real? Yes. You can square root a number and then put a negative sign. Negative root 4 is just negative 2. So we can put a tick there. And yeah. So we'll just work through some scenarios that you might see, just to get your mind thinking about what everything is. So up here, I'll write something and then try and figure out what it would be, and then I'll do it. So A union B. That would be everything inside both A and B. So that would include the bits in both A and so shaded the whole of A and the whole of B. So it include bits that are also in C, but it's just so all of this, all of this. That is A union B. Alright, now onto Venn diagrams. So this will sort of bring everything together. So we've got A, B, C, X and Y inside of X, and then we have Z over here. So we'll just use these to sort of illustrate the concepts that we've learned earlier. So A union B. That would be everything inside both A and B. So that would include the bits in both A and so shaded the whole of A and the whole of B. So it include bits that are also in C, but it's just so all of this, all of this. That is A union B. A intersection B would be this bit in the middle, everything that is in A and B. Now, if you see this, you might be confused with this. So if you just jog your memory a bit, that is A and C, but this apostrophe means not C. So A and not C. So everything that is in A and that is not in C as well. So you'd say not in C. So that means this bit, automatically disqualified. But everything else is fine. So that is A union not C. And we also see down here Z, lonely Z, is all on its own, has nothing in common with anything else. So we can say that Z is mutually exclusive to all of the other things. What that basically means is it doesn't share anything in common with them. Now, from looking at this, we can see that Y is in X. So that means we can write that Y is a subset of X. Over here, I've got a slightly more complicated one, but it's definitely doable. So reading through it, that says B and C or A. So we'll go through this step by step. B and C. So that is this part in here. So we've got that bit. That bit is all done. Now, or A, that just means or A. So we can shade everything in A as well. And that gives us our final answer for B and C or A. Often you will see questions like this, where you're given the amount of people that there are who play a sport or are in a class. So in this case, there's 27 people in a class, in a room. And we know that 19 of them play tennis, 14 of them play badminton, and 11 of them play both. So if you just plugged all these numbers in, you'd get a number higher than 27, which means that something's gone wrong. So what we need to start with is the ones that play both. Because the ones that play tennis could play both, but the ones that play both are 100% in here. So we'll put 11 in here. Now, so we've done this part, all done. Now that we know that there's 11 in the middle, we can find out how many play tennis and how many play badminton. So if there are 19 that play tennis altogether, and there's 11 in the middle, what is 19 minus 11? It's 8. So there's 8 that only play tennis. So we'll just put an 8 there. Excuse my handwriting, it's terrible, I know. So we've done that one. And now 14 play badminton. 14 minus 11, because you have the 11 that's already in this middle part, which play badminton. So then it's just 3 left over here. Now, if we add these all up, 11 plus 8 plus 3, we get 22, which is lower than 27. So you might be thinking that we've done something wrong. But actually, no. That just means that there's 5 that play none. So we've done all that. We've finished this question, and you might have thought it was a bit complicated, but now you should know how to do it. Thank you for watching. Hopefully that helped. Hopefully that was sort of the building blocks to help you kickstart your IB Maths. Hopefully IB Maths made it easy, helped you, and hopefully you come and look at our other videos. Thank you.